In today's video, we are going to go over one of the most fundamental integration strategies you learn in calculus, and that is U substitution. And we're just going to do an example together. So we've got this integral from 0 to 2 of x squared minus 4 to the x times e to the 6x squared minus x to the third dx. So the reason we're going to need to employ a U substitution here is because we have two different types of function. We have a power function, and that is multiplied by an exponential function. So let me start by highlighting a few things. Our integral is in terms of the variable x, and the boundaries of our integral are the values of x that we will eventually be substituting in. Keep these boundaries and this variable in mind as we switch over to the variable u. Knowing how to choose what's going to equal u comes with experience. In general, if you've got an e to the power of some stuff and you're multiplying by some stuff, these are both power functions, it's a pretty good bet that your exponent is going to be the value that you should be using. So once you've got your value of u, differentiate with respect to x. The differentiation is very straightforward. Now solve for dx by treating it almost like it was a variable. We'll just divide both sides by 12x minus 3x squared. Now that we've got a value of dx and a value of u, we're ready to substitute and solve. Again, let me highlight a couple of things so it's easier to follow. Having chosen this u and solved for this dx, the substitution is pretty natural. Now that all of our colors match, we'll do the substitution. Substituting in the u, and now for dx. At first glance, this isn't any simpler. But if you look closely, we can factor out a -3 here, which is going to make our cancellation possible. At some point along the way here, I lost the x. So let's pretend that's been there the whole time. After factoring out -3, you should see the cancellation. You could use a commutative property to switch those two terms around, but you don't have to go through that formal step. You've got an x squared minus 4x and x squared minus 4x. Boom, they're gone. The reason we did a U substitution is so we could make this cancellation happen. And let's rewrite what's left. So that's step one in what's going to be a 3-step process here. First, convert to U so that you can cancel something out to create a simpler integral. But notice how these are still in red and this is blue. We have to convert the boundaries of our integral to boundaries in terms of u instead of in terms of x. Otherwise, we're not going to get an answer that makes any sense. But good thing we have kept track of how u and x are related. It's just a matter of simple substitution and mental math to get to the proper boundaries. 6 times 0 squared minus 0 to the third, it's just 0. Nothing changes but the color. For the right boundary, there's a little bit more work to do, but not much. 6 times 2 squared minus 2 to the third. 2 to the third is 8. 6 times 2 squared, well, that's 6 times 4. 24 minus 8 gives us a limit for integration of 16. So now that we've written our integral as an integral of u and converted our boundaries into boundaries in terms of u, we're ready to solve. The integral of e to the u is itself. The -1/3 comes along for the ride, and now we just evaluate from 16 to 0 or 0 to 16. Always watch out for these double negatives. I call them a sign trap. They can really trip you up. You're doing everything correctly, but you mess up the negatives and you get the wrong answer. E to the 0 is 1, minus -1/3 is +1/3. While this is probably an acceptable answer, let's see if we can clean it up and put it into just a single fraction. When you reorder your terms, remember to keep your sign with the term. And the common denominator of 3 allows us to bring the two fractions together as 1. And this is it. So let's review. It is a 3-step process when doing a U substitution. Step 1, convert from x to u. This is so that you can cancel out some terms that are in your way and create a simpler integral. Step 2, change the boundaries of your integral from x to u as well. Step 3, solve the integral, evaluate at your new boundaries, and then put it in its simplest form.